area of a plane shell is just the amount of the surface enclosed within its boundaries. It is normally measured in what we call square units, which is square units can be square centimeters, can be square millimeters, can be square meters, can be square kilometers, and so on. For example, a square of side 5 centimeters has an area of 5 times 5, which is equal to 5 centimeters. I mean 5 times 5, which is 25 centimeters square. So when you are writing the units of the area, must be in square units. A square of say 1 meter has an area of 1 meter square. That is to say, we have 1 meter times 1 meter, which gives you 1 meter square. Also, the meter will also multiply. So meter times meter gives you a meter square. So while a square of side 1 kilometer will give an area of 1 kilometer square. That is to say, 1 kilometer times 1 kilometer giving a kilometer square. So we can look at the actual conversions in how we can convert from a given unit to another. We know that 1 meter square conversions in area. We know that 1 meter square is the same as 1 meter times 1 meter. 1 meter times 1 meter. But in each meter, we know that 1 meter is equal to 100 centimeters. So here we have 100 centimeters. Times in another meter, we also have 100 centimeters. So that 100 times 100, we get 10,000. And a centimeter times a centimeter, we get a centimeter square. So this implies that 1 meter square is equal to 10,000 centimeters square. That is the relationship between a square meter and a square centimeter. We can also look at the relationship between a kilometer, a square kilometer and a square meter. Square kilometer and a square meter. Similarly, we find that 1 kilometer square is the same as 1 kilometer times another 1 kilometer. 1 kilometer times another 1 kilometer. But in a kilometer, there are 1,000 meters. So in this 1 kilometer, we have 1,000 meters. Then in this kilometer, we also have 1,000 meters. So 1,000 times 1,000, we find that we get a million. 1 million. And a meter times a meter, we get a meter square, or square meter. So this implies that in only 1 kilometer square, we have 1 million. 1 million meters square. So this is how we convert kilometer square to meter square. This process happens even for other units, from millimeters to meters, to centimeters, from centimeters, millimeters, and so on and so forth. So let us look at now area of regular plane figures. Area of regular plane figures. Of regular plane figures. Area of regular plane figures. So, when we talk about the area of regular plane figures, first of all, plane figures, the regular figures are those figures which have a shape, which have shape. For example, we have a square, we have what we call a rectangle, we have what we call a triangle, and so forth. Trapezium, we have parallelogram, we have the kite, we have the locus, and so forth and so forth. Those are figures which have shape. How do we determine their area? To determine their area, different shapes have got different areas. So here, we shall look at a number of formulas which are used for determining the areas of different figures. For example, the area of a square has its own formula. The area of a rectangle has its own formula. The area of a trapezium has its own formula. That's why I'm saying different shapes of figures have got different formula. So we are starting with the area of a rectangle. Area of a rectangle. The rectangle is a figure which looks like this. This is how a rectangle looks like. Whereby this is what we call the length, this is what we call the width. So area of a rectangle is got by the formula length times the width. Length times width. So we can look at an example on how we can find the area of the rectangle. Assuming that we are given a rectangle which looks like this, whereby the length is 5 centimeters, then the width is 3 centimeters, and we want to find the area. That we find the area. To find the area, remember area is equal to length times what? Width. So now we know our area is equal to the value of the length is 5 centimeters times the width is 3 also centimeters, such that the area now gives us 5 times 3 we get 15, and then in centimeter times centimeter we get centimeter square. So the area of that rectangle will be 15 centimeters square. So that's how we find the area of the rectangle. We can go to another shape which we call a triangle. Triangle. So for the triangle, we want to look at the area of a triangle. Remember, the triangle is a three-sided figure. Three-sided figure. Area of the triangle. Before we look at the area, this is how the shape of the triangle looks like. This is the shape of the triangle. So if this is the triangle, assuming that this is the height of the triangle, this is the height represented by letter H, then this is the base, which is represented by B. Then the area of that triangle will be given by a half times the base, then times the height. So area of the triangle is equal by a half times base times the height. Meaning that if we have a triangle, which looks like this, if the value of the height is 10 centimeters, then the base from here up to here is 4 centimeters. We can find the area. So that we get area is equal to, from the formula of the triangle, area is equal to a half times base times the height, whereby the area will give us now a half times our base is the 4 times the height is the 10. By 2 ones, 4 by 2, we get 2. So that area will now give us 2 times 10, giving us 20 centimeters square. That will be the area of that triangle. We can continue. We can look at another shape, which we call a parallelogram. A parallelogram. 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 Now, a parallelogram is any four-sided figure with parallel opposite sides equal. I repeat, a parallelogram is any four-sided figure with parallel four sides being equal. This is the shape of a parallelogram. A parallelogram. This is how it looks like. This is the shape of the parallelogram. You can see that this side is opposite to this and they are equal. This one is opposite to this and they are equal. So, to find the area of a parallelogram, we want to derive the formula for finding the area of a parallelogram. I will bisect this parallelogram into two. I divide it into two by drawing a diagonal. When I draw a diagonal there, you find that we shall have formed a triangle here and then a triangle here. And now for each triangle, the area of this triangle here is equal to by a half times base times a height, which is a half big H. For this triangle also, area is equal to by a half times base times the height, a half big H. So since there are two triangles there, we shall combine the two areas. So the total area of the parallelogram will now be equal to the area of the individual triangles. That is to say, area of this triangle plus the area of this triangle, which is a half big H plus another half big H. So area will now give us a half big H plus a half big H. This a half plus a half, we get 1. And the big H plus big H. There are a half big H plus a half big H. We get big H, that is base times height. Therefore, the area of a parallelogram is equal to the formula base times height. We only get the the base, then multiply by the height given. So if this is the height from here up to here, just to get to the base, multiply it by the what? By the height. However, this is the base and this is the height. That gives you the area of the parallelogram. We can look at another shape which we call trapezium. Trapezium. The trapezium is any quadrilateral. It's a quadrilateral with parallel sides not equal. With parallel sides not equal. This is how the trapezium looks like. Trapezium. This is the shape of the trapezium. So you can see that this side is parallel to this side, but it cannot be equal. So this is the shape of the trapezium. Now, to find the area of the trapezium, we need to know the height first of all, the base, and then the parallel sides. Now, if these are the parallel sides, this is A, then this is B, and then this one is the height, represented by letter H. This is the height. Area of the trapezium would be obtained by the formula I have H into A plus B. That is, I have times the height into the sum of the parallel sides. So area is obtained by I have H into A plus B. I have H into A plus B. So this becomes the formula for finding the area of a trapezium. We can look at it's a derivation. Where does this formula come from? We have to look at it from first principles. So, how do we find that formula? Now, we want to see where this formula originated from. That is the formula for finding the area of trapezium. Now here we said that if this is the shape of the trapezium, this is how the trapezium looks like. That's the area of trapezium. Now, this trapezium here has got a height h. If this is the height of the trapezium, this is the height of the trapezium, which I can represent by letter h. Now, if I divide this trapezium into two, that is, if I created a diagonal there, assuming here I would have formed two triangles. If I name this triangle A, B, C, then the other one becomes B, C, D. So we have two triangles there. Triangle B, A, C, and then triangle D, B, C. Now I'm going to find the individual areas. I will find first of all the area of A, B, C, and then I get the area of B, B, C, after which I add them together. The general formula obtained will be the area of a trapezium, as we are going to see. So here we can start area of triangle, A, B, C is equal to by half times the base. Our base here, I can call it B, if this is the base, small b, times the base, then times the height, h. All of them are sharing the same height. This is the base, but this is the height of the whole trapezium. So this gives us a half B H. Then I also consider the other triangle. You can say from triangle, which is triangle BDC, from triangle BDC, we can also find its area. Area is obtained by a half times its base. In this case, our base is now A. We are considering the parallel sides. The B was for triangle ABC. Now A is the base for triangle BDC. So times our base, which is A, then times the height, which they share, which is the same as H. So that the area gives us a half times A times H. We get a half A H. Then we now get the total formula, the general formula. Area of the trapezium now, the whole figure, which is A, B, D, C. So the area of that figure, which is a trapezium, will now be got by a half B H plus a half A H. Here you can see that a half is common, so I will factorize it. I pull out a half. The H is also common. I pull out the H into B plus A, into B plus A. So the B and the A are the parallel sides. So therefore this becomes the formula for finding the area of the trapezium. That is how we derive it from first principles. We can continue. Let's look at now the area of the circle. Area of the circle. Area of the circle. The circle is a roundish figure. This is how the circle looks like. So, how do we find the area of the circle? First of all, for the circle, we need to know that the circle has what we call the radius. And the radius is the distance from the center to the circumference. So, this is where the radius is. It starts from the center, then goes up to the circumference, represented by small r. So, when we are given the area, the radius, the area of the circle is given by pi r squared. So, the pi r squared is the formula for finding the area of the circle. The circle can be divided into some parts. Part of the circle is what is referred to as a sector. Now, this is how a sector is formed. This is the circle, and then I have this as a radius, and then another radius here. You can see that the sector is formed by two radii. This is the radius, then this is another radius, to form an angle in between, which angle can be angle theta. So the whole of this part of the circle is what we call a sector. Now, area of the sector is got by the formula angle out of 360 times pi r square. Angle divided by 360 times pi r square. So this is area is got by our angle, which is theta, out of 360 then times pi r square. That will be the area of a sector. This same formula here also can be derived from first principles. From first principles also, which we shall not look at this time. We can now look at an example on how to calculate the area of a sector. There is this example which says find the area of a sector. It says, yes, find the area of a sector of a circle of radius 3 centimeters if the angle subtended at the center is 140 degrees. So, we are given that find the area of the sector. Area of the sector, we don't know, we are analyzing the question. Of radius 3 centimeters. Sector of the circle of radius r is equal to 3 centimeters. If the angle subtended at the center is 140, that is theta. Theta represents the angle, which is 140 degrees. Take pi, they want us to take pi to be equal to 22 over 7. 22 over 7. So in this case, if this is the circle, assuming this is our circle, we are going to indicate the sector. So this one here is what we call the sector. They say the angle subtended there is 140 degrees. And they say the radius of the circle is 3 centimeters. They want us to find the area. So we know that the area of the sector is got by the formula angle, which is our theta, out of 360 degrees times pi r square. So that area is equal to our theta is 140 over 360, then times pi, which is 22 over 7, times the radius. The radius is 3, but the radius is square. That means I multiply 3 by itself. When we cancel this, we shall find that our area will now equal to 140 times 22 times 3 times 3. We are having 140 times 22 times 3 times 3, giving us 27,720. 27,720. All over, we are multiplying 360 by 7. 360 times 7. We get 2,520. 2,520. So that now our area gives us, when we divide the above, that is 27,720, we divide it by 2,520, we find that we get 11. We get 11. The units will be centimeters squared. So therefore, area of the sector is equal to 11 centimeters squared. So that becomes the area of the sector. That's how we calculate the area of the sector. There is another example which says the area of the center of the circle is 38.5 centimeters squared. Find the radius of the circle if the angle subtended at the center is 90 degrees. The method is the same. We are told that the area of the center of the circle area is equal to 38.5 centimeters squared. Find the radius of the circle, radius, which is represented by R, we don't know. Radius of the circle. If the angle subtended at the center, that angle is represented by letter theta, and they say it is equal to 90 degrees. How we calculate the radius? Still, the formula is the same. We know that this is our circle. If this is our circle, this is the distance from the center. This one shows the radius. Then we have this distance here. They say that the angle is 90 degrees. So this is how we indicate 90 degrees. So the radius we don't know, but the area is known. So we apply the same formula. We know that the area of the sector is equal to my angle, that is theta, out of 360 times pi r squared. So in this case, our area is 38.5. Is equal to the angle, which is 90 out of 360 times pi, which pi they have told us to take it to be 22/7. 22/7 times the radius, which we don't know, but it's a square. Automatically, this 0 will cancel to this. By 9 ones, 36 by 9, 4. By 2, 22 by 2, 11. So, we shall find that 38.5 is now equal to 1 times 11 times r squared. We get 11 r squared over 2. When we cross multiply, we shall get 11 r squared is equal to 38.5 times 2. We divide here by 11, here also by 11. This one will cancel, so that we are left with the r squared is equal to 38.5 times 2. We find that we get 38.5 times 2. we get 77. Divided by 11, we find that we get 7. So we get what? 7. So this is r squared is equal to 7. But we are interested at getting r. So it means that we have to remove the square. How do we remove the square? By bringing square roots on both sides. So we can get the square root of r squared, which is r, and the square root of 7 is 2 point square root of 7. We can leave it in sandy form, which is root of 7 centimeters. Centimeters only, not the square. Because we are calculating the radius, which radius is in length. So this one is in centimeters. Centimeters. The value of the radius. That is how to calculate the radius of a sector. So we can now look at surface area of solids. Surface area of solids. When we talk about the surface area, we mean the area of the flat surface. Different shapes have got different surfaces. When we look at the cuboid has got many surfaces. Surfaces are the faces of the figure. The cuboid has got 60 faces or 60 surfaces. If we are to find the area of a cuboid, we get the area of each face. Area of each face, after which we get the sum of all the areas of the faces to give you the total area of the of the cuboid. Total surface area of the cuboid. So we said that from the cuboid, we are looking at the surface area of shapes. For a cuboid, this is how it looks like. Cuboid. Unfortunately, I don't have it there. So in cuboid, this is how it looks like. This is how a cuboid looks like. It looks like a box. So you can see that it has 60 faces. It has what we call the length, the width, and then the height. So if we are finding the surface area of the cuboid will be equal by the formula 2 into, we consider the base, that is length times width, plus 2 into length times the height, then plus 2 into width times the height. This one will be the surface area of the cuboid. In other words, the area of each face is multiplied by 2. That is according to the surface area of the cuboid. We have other shapes, like, for example, cylinders. We have prisms, all have different surface areas. We can look at another shape, which we call the triangular prism. To find the surface area of the triangular prism, Remember the triangular prism has got five faces. Has five faces. The triangular prism has got five faces. It has five faces, and this is how it looks like. This is how it looks like. This is a join with that. This one for this. And this one for that. So this is how the shape of the triangular prism looks like. So it has five faces. This one, the other one, this one, and the what? The base. It has got five faces. Now, how do we find the area or the surface area of the triangular prism? To find the surface area of a triangular prism, you need to get the area of each face. Area of each face, after which you get the total of them. Now you get this face, then for the other face, you get their area also. You get the face and the area of these cross-sectional areas which are triangles, then the area of the base. Then you get the total, to give you the total surface area of a triangular prism. So there is a question which says find the area, the surface area of the triangular prism shown below. Shown below. Example. They want us to find the surface area of triangular prism shown below. So we have the shape which is in this form. This one here. This one, join there. Then I have this. This one, 90. This one also 90 degrees. So we are told that this is 13 centimeters. This is 13 centimeters. This is 5 centimeters. And then this is 2 centimeters. 2 centimeters. So this is what we call a triangular prism. Now we want to see how we can find the surface area of the triangular prism. To find the surface area of this triangular prism, we shall get the area of cross-sectional parts which are in form of a what? triangle. So we shall say solution, surface area of the two triangles is equal by the two triangles. Remember, area of the triangle is equal by a half times base times height. But since there are two triangles, to multiply by 2. So in this case, we shall have a half times the base there is 5 times the height is 2. Then everything times 2. You can see that these 2 will cancel with this, and we are left with 5 times 2, which is 10 centimeters squared. So that's the surface area of the two triangles. Then, when you look at this diagram, there are two adjacent rectangles. One this side, another one there. Two faces. So we shall say also surface area of the two adjacent rectangles is equal to by length times width. But since there are two of them, to multiply by 2. So we shall have 2 into the length is 20 times the width is 13. So this gives us 20 times 13, we get 260. 260. And 260 times 2, 260 times 2, we get around 520. 260 times 2, we get 520. 520 centimeters square. Those are the two adjacent rectangles. We are left with one face, which is the bottom. And that bottom one is also a rectangle. So we shall now say surface area of the rectangular base. Rectangular base. The base is only, that rectangular base is only one, and its formula is equal by length times width. So whereby our length is 20 times the width is 5. So 20 times 5, we find that we get 100 centimeters squared. So therefore, total surface area we will now equal by adding the areas of all those. So we get in 100 plus the other one, which was 10 plus 10, then plus 520 plus 10 plus 520. Okay. Plus 10, then plus 520.